Okay, so I realized last night that my recording for question 4a and the video for question 4a were not synced together properly. So this is a repeat of question 4a. This question is slightly different from the others that we've seen so far in that we have a product on the bottom. And sure, we could expand it out and see what we got, but it wouldn't. This top line still would not be a nice. It would still not be the derivative of the bottom line. So it's not a nice quotient per se. But it turns out we actually have a tool for splitting up a product in the bottom line of a quotient. And that is our partial fractions. And really this is the reason why we need to learn partial fractions at all, because it really simplifies our integration. So I can write this as x divided by 2 take x3 plus x is equal to a, some constant, over 2 take x, plus b, another constant, over 3 plus x. And that of course means that x is equal to a, 3 plus x, plus b, 2 minus x. Now, ideally what I should be doing is I should be expanding this out and looking at the coefficients. But because this isn't actually an equality, this is actually an identity, that means that I can do this for any value of x. So it's easy to just substitute in a value that makes one of these disappear. So for instance, I can substitute in x is equal to 2. And what does that mean? That means that 2 equals to a, 3 plus 2, plus b times 2 minus 2, or 0. So that means a is going to be 2 divided by 5. And I can do the same trick again by setting x is equal to minus 3. Then I get minus 3 is equal to 0a plus 2 minus negative 3. So 2 minus negative 3b. So that means that b will be negative 3 upon 5. So now that I know that, I can rewrite my integral, can't I? So what was initially this up here, I can rewrite this as, so the integral of x over 2 take x 3 plus x dx is actually equal to the integral of 2 over 5 divided by 2 take x minus 3 over 5 divided by 3 plus x dx. And now if you look at it, it's very, very easy for us to integrate a constant over 2 minus x, and just as easy for us to integrate a constant over 3 plus x. We know how to integrate these already. How? Oops. Not quite sure why we went there. There we go. Let's just go down here. Sorry about that. So it's very easy for us to integrate these. How? Well, this is the same thing as 2/5 times the natural logarithm of 2 minus x when I integrate it. And then of course, because I have a minus sign in front of the x, that would come out, so I need to get rid of it somehow. I bring the minus sign out the front again. Minus, and again, 3 over 5, the natural log of 3 plus x. And of course, as with any integration, I need my constant of integration at the end. So the trick with all the questions in part 4, all the questions in question 4, is to use partial fractions to separate them up into things that we can integrate fairly simply. So we get nasty products that we can't integrate, we use partial fractions, and they separate out into nice quotients that we can integrate. That's the trick.